I'll give you an example. I work for a phone company, and what we have, our problem is rate data. Okay, so a phone call is carried by certain carriers, and it took place at a certain time.
Right.
And the rate tables say, effective this time, this is the rate for carrying. And you know, I mean, it's more complicated than that because you have your NPA and NXX and the originating part and the terminating part. So this table says, effective a certain date, a call from this number to that number is going to be this amount of money per second. Okay, and they give us the rates in advance, and we publish our own rates in advance, and they have an effective date. Okay. They don't have a termination date.
That's right. Events, those are event-based inputs.
Okay.
That's a good, you gave me a perfect example of an event-based input.
And now, when the end of the time period comes up and we invoice one of our customers for the phone calls that they made, the first time we do that, it's during the regular invoicing period, and we want to know what the rates were during that time period as they changed for each of the days, because for each call record, we're going to rate that call record, and that has a date and time stamp when it started. And so we know what rates were in effect from this table. We have to find what rates were in effect. And generally, you get the same rate for the whole phone call, but there are exceptions. And sometimes they want the rate to, if you have a phone call that takes place before midnight and there's a new effective date, they might want to get that new rate for the next day. Worse than that, there are mistakes in the rates, and they are then corrected, and now they want an invoice for October. Okay.
So perfect example of bitemporal data.
They want to be able to pull the invoice for October the way it was on October 31st.
You brought in a straight man.
Compare that to the invoice for October after we fixed the rate table.
You know what you need?
What?
Bitemporal data.
Darn, I was thinking it might be that. Wow.
Perfect example. Can I take you to Boston with me tomorrow?
Wait a minute. Can you answer me this? What time zone?
Okay, that's another.
You call Colorado.
Hey! No kidding.
Right?
That is a great example.
Right,
that is a great example for a real-life need for bitemporal data. You got a nightmare with that, right? You got a nightmare with that right now.
Well,
right?
day too, because you can't even tell what time zone the nightmare is.
You got a lot of nightmares. But the specific example that you described, you know, of the corrections to the rate changes and people wanting, you know, they want to know what the rate. What we thought the rate was at a past time is a perfect example.
They want to know what was presented and compare that to what.
Right. So what did we think the rate was on the third? On the fourth, what do we think the rate was on the third? On the second.
The customer may argue with our version of what we think the rate is, and so then we have to be able to establish that we did think that at the time. And it was only later on that somebody provided us with other
So again,
information.
perfect. You had to establish what you thought it was at the time.
Right.
Okay. Think financial services. Think regulators. Okay. Now you're getting a sense of the power of bitemporal data, right? And you know, as I told you up front, these things that you're asking for, only bitemporal data can do them. You know, there's workarounds, and we're going to get to some of those workarounds. Okay. But the type of things that you're talking about. They can only truly be supported by true bitemporal data. There's workarounds that can get you close, or that close may work for you, or it may not. And if you're betting billions of dollars doing algorithmic trading, it's not good enough. Anyway, so that was great. As I said, I got to take you to Boston with me tomorrow.